Hi everyone, I'm Mikhail. Welcome to the Dark Wire Labs YouTube channel, where we break down network technologies and bring them to life with real code. In today's video, we dive into the Zero Trust security model to understand how it defines Zero Trust network access. We'll examine its architecture and then build a custom endpoint agent for Windows from scratch, using Go language to demonstrate these principles in action. The Zero Trust security model is a security approach where no user, device, or network is trusted by default, and every access request is continuously verified and granted least privileged per application access based on identity and context. So let's review core principles of the Zero Trust model. Never trust, always verify, meaning every access request is authenticated and authorized, regardless of location. Identity over network means decisions are based on user and device identity, not IP or network position. Least privileged access. It means that need to grant access only to specific applications and actions, nothing more. Assume breach. Design your infrastructure as if attackers are already inside. Prevent lateral movement. Continuous verification. Access is reevaluated continuously and can be revoked at any time. Last one, minimize attack surface. Applications are hidden and reachable only through policy control access path. And I'd like to add that zero-touch network access is the evolution of the VPN, moving from network access to application access. Now let's review architecture of our endpoint agent. The purpose of this endpoint agent is to demonstrate some of the core principles of the Zero Trust model in action. The idea is to block all outbound HTTP and HTTPS connections while a user is unauthenticated. After successful authentication, access is granted on per application basis. The agent will have flow monitor implemented to maintain a real-time port-to-process ID mapping, so our agent will always know which process initiated certain connection. Another task is to identify destination domain, what is normally done by implemented full interception of HTTPS traffic. But in our example, we'll use another approach for simplicity and intercept DNS traffic to match domain names to server IP addresses. Our policy engine will cache these mappings to analyze new connections and enforce the policy. We'll use external library called WinDivert, which operates at kernel level. We'll use kernel to user space bridge to pull packets into our Go policy and enforce policy decisions. In our demo, we'll implement 4 policy rules. The first rule is to deny all connections if a user is unauthenticated. Second rule, for authenticated users only, to permit Chrome browser to access .com domains only, and to deny access to any other domains. The third rule is also for authenticated users only. It's to permit Firefox browser to access any domain but route traffic via a VPN tunnel. And the last rule is to deny all other outbound HTTP and HTTPS connections from any other Windows processes. So now let's take a look at the Go language code, what was created by AI agent for my requirements. So first let me show you content of the folder. So that's our Go application. And these are two WinDivert libraries that we'll be using for intercepting packets from the kernel and also to enforce policy decisions. We need to put these files in the same folder as our main file. Let's quickly look through the code to get some basic understanding what it does. So, first of all, on the start, it will look for the WinDivert DLL file, and it will not continue if the file is missing. In the beginning, the agent asks us to enter username and the password. Here, for our demonstration, we didn't implement proper authentication through any identity provider like Active Directory or any other identity source. We just created simple condition that if the username is Mikhail and the password is this, to grant access. Of course, that's only for the demo purpose, and you will never see it in real life scenario. Also, we implemented a function to find a VPN tunnel interface, and I'm going to use WireGuard. So we didn't implement VPN tunnel in this program. We'll use a VPN tunnel from WireGuard, from just another process. We will only route packets through that interface. I just remind you that one of the conditions in the policy is that if you are accessing internet from Firefox, all your traffic should be routed through this VPN tunnel. So this function helps us to get netstat statistics of all ports and process IDs in order to match TCP connections to process IDs. What we'll need later to identify the process which initiated certain connection. Okay, that's one of the main methods here to run the packet enforcer, where we are getting the packets from the WinDivert library. Let me scroll it down till the policy enforcement. So that's the policy. So if the process name contains Firefox, then we are going to redirect it in the tunnel by changing the interface, and also we are going to perform net address translation by modifying the source IP address, just to make sure that return traffic also comes back to us, and also to make sure that the destination resource doesn't see the real IP address of the client. All right. Another rule is allowing access to .com domains from Chrome. And last rule is to block all other connections. I need to add that in the real life scenarios, of course, you cannot rely on the process name. You will need to use some other criteria, either some hash, and for example, just to make sure that this process is really a legal Chrome, but not some malware file, which was just renamed to chrome.exe. All right, another method is our DNS monitor. Since we didn't implement full TLS interception of HTTPS traffic, but we want to know the destination domain names, we are going to intercept DNS traffic to get mappings of the domain names and IP addresses of the servers. Of course, that method is not too much reliable, but it's sufficient for our demonstration. Yeah, so that's the methods to get the name of the process from Windows system. It's using some Windows API to get this, and basically that's it. So I built this program in the executable file ZT Agent, and I'm going to run it, but I need to run it on behalf of administrator because otherwise we'll not be allowed to intercept traffic and enforce policy decisions. Right. So now we are in the right folder. Before running this agent, we need to clear DNS cache because, as I explained earlier, our program is intercepting DNS, but if some DNS request and response were cached previously, the browser will not initiate another DNS request, so it will use system cache. So I'm going to do flash DNS, and let's start our agent. So first we need to get authenticated, because as I explained earlier, if we are not authenticated, all traffic is blocked. And let me just show you. Yes, I'm trying to navigate to Google. It's not loading. Okay. Let's restart the agent. Now I'll authenticate properly. Okay. So as you can see, it started blocking some requests from my Chrome process because they were not destined to .com domain. Let me close the Firefox first because we are going to check the Chrome rule. Let me actually restart this. I need to say that this login and in general the way how we are intercepting and blocking things, well, this approach is not cannot provide high performance, so because of that all requests, all connections are slow, but that's okay for our demonstration. So here I'm opening google.com and you see it's loading. And also, as you know, for any website, there will be multiple connections to other domains, like with some static content and then some tracking sites and so on. That's why not all the content is loaded, but here it's loaded. And search, yeah, it's loading. Now let's try something. Okay, it's blocked. Ping EU is blocked. You see, it's not loading. Good. Our policy is operational. Now I want to show you Firefox example. For Firefox, we are allowing all traffic, but we are redirecting it to a VPN tunnel. Um, yeah, there are quite a lot of logs here. So I'm just accessing websites. It's pretty slow, but it's loading. Yeah, as you can see, it's really slow. It will load eventually. Yeah, eventually it's loading. But as I said, yeah, our demonstration is not really performant, but at least traffic is routed. All right. So just to summarize what we did today. So we discussed core principles of the Zero Trust security model. We spoke about Zero Trust network access, and we discussed the architecture of our endpoint agent that helps to implement some of the Zero Trust principles in practice. I hope you enjoyed this video. Thank you very much for watching. See you next time.